Okay, so the idea with the water slide, basically you have two pieces. Let's do it in dark blue seems, damn it, dark blue seems appropriate for the water slide. And we know how that works, right? So something goes in at the top and it gets flushed out at the bottom. So that's the life of a water slide. Now, essentially what we're going to do with all of these Java classes, we're going to do one or two or three, well, two or three of the following things. First, we'll specify the source or the destination file. Okay. And by default, the other end will be the device, well, we'll just say RAM. RAM on the device running the program. Okay, so we're either one of two options. Either data from RAM going to file, or data from file going to RAM. Okay, very simple. And either way, something's going to go in at one side and go at the other. So, for example, first, in a typical thing, we'll specify for an output operation. Okay, so output in this context means RAM to file. I'll say disk, but you know, an input means file to disk to RAM. So if we're running an output operation, right, we want to save data to our disk, we first specify the destination file. Then we essentially create a stream object, a stream class that sends the data, right, that accepts the data, and sends it to the file, okay? And we possibly an additional type-specific file, stream file. So this first one is going to be for a byte array. Okay, that's the basic format. Whatever we're sending out, right, it needs to be as a byte array. And then, right, if possible, we're going to send that out as an object. Okay, but in fact, it works the other way. I'll change this. So for example, if we're doing multi-step, right, actually what I should do is this. I should move this up here. These steps go the other way. So if we're only doing one step to the water slide, then this is what happens, right? We send it out as a byte array. But I should pull this up. Okay. But if not, right, we always have this byte array at the bottom because that's how the data needs to go to get to the disk. But that's fine, I'll leave that. But if we do this one, if we're doing, for example, for an object, then we would convert the object to a, we'd send the object in, and then we'd send the object itself to get converted into a byte array before it got sent to a file. So in any event, all we're ever doing, we only ever deal directly with one of the stream classes. So we have one or more stream classes that we use to send data to this file, but we only push it into the first one. If there's more than one, we push it into that one, it automatically goes to the second one. Okay? We push data into one of the streams, and it gets carried along through all the others. Okay, and it works basically the same way for reading data. Again, we specify a source file, we specify one or two streams, we start reading in data from the stream file, and if necessary, we read data in from one of the stream files. If necessary, we have to build on additional stream files to pull the data from the file or convert it into different objects. So that's the basic idea. If that seems a little weird, well, hopefully it'll make a little bit more sense by the time we get into the lecture, or by the time we're done with the lecture. So this, again, is an old set of slides, but I use it because it still works. So yeah, there we have it. So we're going to skip this first thing, this JFile chooser. That is basically a little pop-up window that lets you select files. We're going to do some basic file operations today. First, we're going to read bytes to a file, read them back from a file with our two basic stream classes, file output stream, file input stream. Then we're going to do primitive data types. Okay, so again, our basic numbers. We're going to send them to a stream using data output stream, data input stream. Then, well, we'll probably skip this. I'll mention it, I'll talk about it, but it's not really essential. These print writer and buffered reader, they're a set of classes, they've been deprecated. I'll talk on Wednesday about what followed up after them. Maybe I'll even post up an updated set of slides. I'll probably have time. And last, the relevance. So these classes are relevant because they handle strings more efficiently than the other types. That's why they're important. So if you're dealing with data that's a lot of text strings, sure, there are some classes that are more or less specialized for that. Otherwise, you can just use these generic object classes, object input stream, object output stream, that handle the conversion process from primitives. So essentially, they read all the data from the object, and they contain the structure of how the object is supposed to be. And as long as the structure in the file matches the structure that is actually present in your local machine, then everything's fine and it pulls the data in. Okay, so that's what we're going to cover. We're going to cover basically these different types of file handling. Now, first place to start, sure, I'll enable editing. First place to start is with the file class. So in order to do anything with a file, we have to create a file object. And file objects and most of these input-output classes are in the java.io package. So let's say file in file equals new file. And here we're specifying from the local directory sample.dat, or we can specify a complete file path. So here C sample programs test.dat. So either format is fine. It's just if you only have the file name, it's going to assume it's from the local project directory. So let's make some files. We'll make some Java classes. Okay. So first one, we'll call it fun with files. Give it a main method. You don't need to create that from scratch. Okay, we're going to import the java.io package right off the bat. And just bring in the whole thing. Okay, so what shall we do? Let's make a simple program to save some bytes and read some bytes. Okay, not going to be very exciting, but that's okay. So we'll have two methods, void save bytes, and this method will write some data to the file. And then we'll have another method. This method will read some data from the file. Right? Not too complicated yet. So void load bytes. And of course, in this context, saving means the same as writing data to the disk. Loading means reading it from the disk. Okay. So we're going to give ourselves a file object. So call it file. You know, we're not going to do it as a class, so that's fine. So we're just going to call the two methods to start with. So for this one, we're going to do ending. Okay, and then what we're going to do, we're going to call save bytes, and then we're going to eventually call load bytes. We need to create an object. Let's do okay. So again, first line here, we're creating the fun with files object. We're just printing out a message. We're starting something, we're ending something. This is the whole scope of our program right here. And then we're going to call the save bytes method to write some data to disk. After that's done, we're going to call the load bytes method to read that same data. Okay, so at the end of this, I'm going to have some diagnostic message. Data successfully saved. Here, I'm going to write data successfully loaded, and we'll see what happens at some point with that. So the first thing we want to do is, again, we're going to build the water slide. Now, this water slide is going to be very simple. There's just going to be a file class and a single stream class. We'll start with this. So file F equals new file. Well, let's pop up a folder here. Well, I just put it in my JavaScript directory. Let's see. Desktop and go up, up, up. Whoop. My workspace. And here in the source folder, we'll see where stuff arises. I don't have anything else there. Okay. So new file, we'll save it to the local directory, and we will call it, what shall we call it? Bytes.dat. We're very creative today. Okay, so that's where we have it, and it'll get saved to the workspace. And then next thing we want to do, so first, specify the file, the destination file. That's what we're doing here. Next, specify the byte array. Okay, so we can do something like byte array B equals, let's see if we can do this. Use the same example from the slides. Good, like that. Okay, so that's our byte array. This is a shorthand. If I want to, right, we're using squiggly brackets to create the array, right? So that's all I'm doing. Here I have an 8-element array that I'm just creating. B is that array. Okay, so we specify the byte array. We use the squiggly brackets to create it. Next thing, we're going to create a file output stream. So file output stream, FOS, new file output stream, and we have to affiliate it with our file. Okay, now we see we have an error here. Well, let's talk about that in a second. So here, create the file output stream, okay, affiliated with our file. This is the data water slide for our byte array. So essentially, once I send something to this file output stream, it's going to get carried straight to the file, right? So the file is the endpoint. I've created the stream affiliated with the file. Java knows if I push something into the output stream, it's going to get pushed out at the other end into the file, and I don't have to worry about any of the details. So again, this is a wonderful thing. I don't have to code all this stuff by hand. I don't have to get into the details. Java does that work for me. Very, very nice thing. However, there is an error, so let's look at it. Multiple markers at this line. Okay, two things. If you look, first one, it says unhandled exception type, file not found exception. Well, that means there's an exception type I have to handle here. And for those of you who were paying attention during the exceptions and assertions lecture, you may recall I mentioned that file input output in particular has a lot of checked exceptions. Well, one of the things is, if I try to run this stream and there's nowhere for the data to go, that's going to throw an exception. And again, we wouldn't want our whole giant enterprise scale application to fail because of some easily caught error like this, right? It's a foreseeable thing that for whatever reason, the destination file is not available. The hard drive is broken down, or the request times out because the hardware is too busy, whatever. We got to have some mechanism there to fail gracefully. So I'm not going to worry too much about that. I'm just going to embed it in a try-catch sequence. Okay. And here I'm okay. So this is the exception that expects to be handled. That's fine. Okay, so if it does, I can print out something, system.out.println, file not found. Oh no. Okay, so something like that. I'll do it nicer. We're sorry. The file you wanted was not found. There we go. That seems very nice. Okay. So there's that, and let's bump up that bit. Okay, so every one of those we have an issue, right? With it's all fine. Where are we going here? Next thing we got to do, all right, so we got to specify what we're pushing in to the output stream. So we have a write method for that. Okay, so file output stream has a write method. We'll use it. Okay, so fos.write, and we can send along a byte array. Ta-da! Okay, so these are for different things. If I use this, I could write one single specified byte, which is a little odd. This one, I can use some stuff in an offset, right? So I could put things that basically like in the middle of the output stream, for example. Anyway, but here, if I just want to send this as the complete byte array, yeah, I can do this. I'm going to do this. I'm just going to send along B. Well, why didn't you like B? Ah, the IO exception. Yeah, so again, there's another one here. I was wondering, usually I just bundle all the things together into one exception, but yeah, there's multiple ones that can happen. So unspecified input-output exception. Okay, so we have that. If there's a couple of different checked exceptions involved here, file not found and input-output exception, there they are. But as long as everything goes through, then I get this data successfully saved, right? Otherwise, these exceptions, I should put this up here. Otherwise, the exceptions will happen. Okay, so if I reach this point, I'm good. The data has been saved. Okay, so let's check this out. Let's run it, and we'll verify that we have some data in place. Zoop. There we go. Well, we didn't actually successfully load the data, but that's okay. The application made it all the way through to the end. So let's see. We ought to have, there we go. Right here in our project folder, we have bytes.dat. There it is. Okay, it wasn't there a minute ago. It's there now. If we look at the size, if you can see the hover over it, it says 8 bytes. So that's a whole lot of data there. That's 64 ones and zeros. Well, 64 ones or zeros. Okay, 64 binary digits. All right, load bytes basically works the same way. So again, we're going to have first specify the file. There are a couple of changes. So we're going to have file f equals new file, and we can specify the same location, bytes.dat. Okay, so again, in this case, specify the source data file. And the second thing, we're going to create a byte array to hold the data. Okay. So specify a byte array to hold the data. So we'll just do byte array B. All right, we can do something with that later. We can make it a little bit more compact. I'm just structurally keeping it the same as the other one. Then we're going to try to create the file input stream, and we're going to read it into B. Okay. So again, specify the file input stream, read and store the data in B. Okay, so once again, file input stream, FIS was new file input stream, and we affiliate it with the file. Okay, again, affiliated with our file. And once again, we see there's some error. So it says here, multiple markers of the, oh yeah, you know what? I should correct the resource leak here too. So sorry, I digress. So all of these streams, I have to do it inside. Keeping all of these streams open basically consumes resources, right? It's something that the computer has to check periodically if anything is happening with the stream. So, and it has to have memory available as a buffer to, you know, read any data going out. So it's good practice. If I'm not doing anything with the stream, right? If I'm done with it, then I close it to stop the associated, let's say, to halt associated resource usage. Okay, so anytime we're doing this stuff, we want to close our streams after we're done. It is good practice. Okay, and again, we have this, the FIS, our file input stream. We need to embed that in a try-catch sequence. Okay, so I'm going to have the couple of statements I do here. So once again, I'm just going to borrow these because it uses the same ones. Okay, found exception E and IO exception. So first thing with the file input stream, right? What are we going to do? Well, we're going to find out how big it needs to be. I'll show you in a second here. We look here, here's basically the same thing. If we read, again, what we can do from here is read file size. So file size we can get from our file. Okay, that's a neat thing. So I'm going to do that inside the try-catch though for myself. So where's my, there we go. Read the size from the file. Okay, so B equals new byte array with the size f dot where's my size? Sorry, I'm a little fuzzy this morning. Get length, it's just length, yeah. Is it get length? No, just length. Okay. That's what I was thinking, and I zoned out a bit. Okay, so new byte f dot length. Why doesn't it not like that? Can I convert from long to int? Oh yeah, so I gotta convert that to an int. Okay, so I'm reading the size of the file as an int, and I have to hope and pray that it is not in fact larger than 2 gigabytes, because that'll really throw a wrench into things. Okay, so B is that is the size of my byte array. Then I can just read in the data. So then read the data from the file. Okay, so B equals, oh, I don't know why I'm fuzzy today. I just read it. Yeah, I associate the byte array, fine. Equals FIS dot read bytes. Sorry, I'm a little. Things are a little strange this morning. I don't know what's. I hope they haven't changed some stuff here. What is the problem? Oh, sorry. Okay. Sorry, this is, I'm a little fuzzy this morning. Kids were a bit of a handful last night. Anyway, read the data from the file and it gets stored automatically in B. Okay, so here, essentially, I'm sending along B as the reference to the read method, and then Java knows that this is where it's going to get sent. When I send along the array reference B, that's where the data goes. Okay, so at this point, basically B will be full up of all the array data. So then I can do a for loop, simple for loop, for int loop equals 0, loop less than b dot length plus plus. And for each one of these, you know, I could do system dot out dot print line loop. I just do index just write it out. Okay, so I'm just going to write out the contents of the array. Okay, and again, if I reach it to the end here, right, so I have a couple things. Loop plus plus. If I reach to the end, then I know that all is well. Okay, and I have to do FIS close at the end for the same reason, right? I want to close this stream. All right, so go back through this again. First of all, and create the file input stream. That's where I'm building the water slide connecting the file. Right after I've already specified the file, if I want to pull data from that file, I use the stream method to do it. Then I specify the container, the receptacle that all the data structure that all the file data is going into. For the byte arrays, I read the file itself. I send along the reference of the array, that's where the data goes. You'll see with the other ones it's a little different. And then just for fun, right? Here we print out the array contents. And then again, if I reach to this, I say data successfully loaded. Ta-da. Okay, so let's run this. Let's see how it goes. There we go. Data successfully saved. All the indexes are correct, right? Data successfully loaded gets printed twice for some reason. Oh yeah, there it is at the end. Okay. So that's how it's done with your basic byte arrays. Questions on this? Does this all make sense? I hope it does. Okay, now as you know, as you may guess, we don't deal with byte arrays all that often, right? We'd rather deal with objects. So the next step on the water slide, as applicable, is to set up some kind of conversion where we take this data, right, whether it's a stack of primitives or a stack of objects or a mix of all of the above, and automatically convert that to a byte array. Okay, that's the next thing. So I'm going to finish, I'll go through the rest of these slides here to get to that point. So low-level file input, this is the basic structure. Now, when these slides were written, I should mention they weren't checked exceptions involved. You could just run all this stuff back when, but then at some point down the line, like about 10 years ago or so, they started enforcing checked exceptions for all this stuff. So again here, you set up the file, set up the stream, set up the array to read the data, ta-da, okay? Just like before, we set up the file, set up the stream, define the array that was going to be sent out, we write that to our stream, and then we close it down. Okay, so this one, next one, we'll introduce data output stream and data input stream, okay? Now what these two do, let's, data output stream and data input stream allow saving primitives, right? Reading and writing, saving and loading primitive data. So they automatically convert to and from byte arrays. So all we have to do is either read the primitives or save them, write them, but we need to do that in the proper order. Right? Basically, first in, first out. Why is that? Well, if, for example, suppose I'm saving, I'm going to have something, this, let's say that's an int, and this is a long, right? So this is 4 bytes. and this is 8 bytes. Now, if the file just has a 12 byte array, it doesn't know the intended sequence, right? All I do when I save it as a byte array, I'm just saving 12 bytes. So if I read the 4 bytes and then the 8 bytes, it gets it in the correct order. But I could, for example, read the 8 bytes. Damn it, this is harder than it looks. I could read the 8 bytes first, and then the 4 bytes. Ah, that's horrible. Or, you know, I could do it like this. Let's just bounce it over here. Okay, I could do it like this, or I could do it, you know, equivalently, right? A string of 3 4-byte sequences. When I say a string, I just mean a sequence, right? I could do it like that as too, and any number of other ways. I could just break it up into 12 single byte values. So it's important that you read data in the correct format. So let's go ahead, we'll get through the stuff. Basically what we do, we have our write options, right? So for example, we write int, write float, write double, whatever. We send that to our output data stream. That passes it along to a file stream, and that passes it along to our file, okay? So we'll do that. So again, we're gonna have 2 methods. I'm gonna comment these out so I don't have to see that same stuff all the time. We're gonna do fwf.saveData, and then fwf.load data. Okay, so they don't exist yet, so let's make them. Void save data, and then void load data. Okay, so first structure, let's say I want to save a sequence of, I don't know, an int and a double and a char. Save an int, a double, and a char. Okay, so I'll do int I equals 1, double D equals 2, char C equals the character for 3. Okay, great. So those are our data. Here's the file. I'll do the file first. So specify the file once again. I'm just going to copy a lot of this because I don't really need to reinvent the wheel for everything. Okay, so I'll call it data.dat. Then I have this try catch thing again. Right? So once again, I'm going to need to do a try catch. I'm just going to do it right off the bat here. And I'm going to put all these things at the bottom. Okay, so I'm going to try to first link up the file inputs, file output stream. So create the file output stream for the byte array to file. And then the second thing, create the data output stream for the primitives to byte array. Okay, so here I'll have file output stream FOS, new file output stream affiliated with the file, just like before. And for this one, I'm going to affiliate the data output stream with the file output stream. So data output stream DOS equals new data output stream FOS. Okay, so I've affiliated that. I've built the water slide. The data output stream goes to the file output stream. The file output stream goes to the file. Anything I push into the data output stream will automatically get carried forward to the file. So, and push data to the data output stream. So, dos.write, and there's a bunch of different type specific. You can see here type specific methods. For example, write double, write char. And you can even have other ones where you send chars, a group of chars as a string. It's a lot more flexible than it used to be. Once upon a time, it was very specific about the things you could send along. I'm going to first send int I. And then I'm going to send along a double, write double D, and then send along a char C. Okay. And then afterwards, as usual, if I reach the end successfully, I know everything's good, and I'm going to close all the streams. Okay. Close the streams to halt their associated usage. Okay, so FOS.close and DOS.close. We're going to take care of both of those. All right, I put them all on the same line. Doesn't matter. Okay, so let's run this. So right now, let's see, there's nothing up in my workspace, but in a moment there will be. So there's my bytes. That's the same way this one's going to go. So let's save it. Data successfully saved. Let's pop that up. Boom, there it is, data.dat. Okay, and I can read it the same way, essentially. So once again, I'll have these three data structures. Put this here. Okay, so I'll have save, yeah. So I'm going to initialize them. Initialize to zeros. You know what? I'll even set the char to be a 0. Okay, that's great. Okay, so once again, I'm going to do this whole try-catch sequence. Okay, but I'm just going to pull all this. I'm going to pull this whole block and change what I need to change. Okay, so the first thing, we're creating a file input stream, right? So file input stream for file to the byte array. Okay, that much has not changed. So this is correct. I have a file input stream there. It's going to take all this data from the file, put it into a byte array. But I don't want to leave it in a byte array. I want to put it in these other primitives. So for that, I need a data input stream. Okay, so data input stream, new data input stream. I guess I should have just used Control F to update all those. All right. So then, next one, going to read all the data to the data. All right, so we're gonna do this anyway. All right, so I can at least do find out replace with in. There we go. Okay, so let's do it. We'll say I equals DOS dot read, and again we have our bunch of methods. Okay, so I have a read int that basically pulls 4 bytes off of the file and assigns them to an int. Likewise, D equals DOS dot read double, and C equals DOS dot read char. Okay. Anyway, if I reach this point, the data has been successfully loaded. So I'll close that. So, yeah, that'll work. Boom. Okay. And then afterwards, we close our stream. So again, let's create these. FOS should be FIS. And DOS will be DIS. Okay. So that's it. Right now, we can read that, and we'll see, we'll display the data. So system.out.println, I just do it all on one line. So plus I plus D plus C. Okay, so we should have here, right, 1 plus 2.0 plus 3. So that's what our stuff will show as. There we go. 1 and 2.0 and 3. And life is good. Okay. Now, again, if we start reading stuff in a different order, then everything can go off the rails. For example, if instead of, I swap around I and C, then some different stuff is going to happen. It's still the correct number of bytes, still 16 bytes, 14 bytes total, 2 for the char, 8 for the double, and 4 for the int, but it's read in a different order, right? So everything's going to be screwy when I do this, right? See, it displays a completely oddball number, no longer really there. So the order that you keep these things in is very, very important. Otherwise, everything goes really weird. And again, it's a little bit odd that, you write the stuff in the same way that you read it. But what happens in practice is this. So your stretch of data, the track on your disk, whatever, is a long stretch like this. And the drive head, basically moves in one direction along the track. And so if your first thing's here, if you have an int and a double and a char, well, you write them that way in order. You fill up the buffer that way. This is how it gets written to your disk. And then when you read it, again, you scan down the disk that same way, and you read that stuff first and copy it into your buffer in memory. And that's where it goes. So reading and writing are not as different as you might think. Anyway, they both involve the disk being scanned in the same direction. So it's natural that they get, stored that way and loaded that way. Okay, take a minute to go through these examples here. Where's my stuff? Okay, so again, this is for output, and in this case, they send along a bunch of different things here. They send along an int and a long and a float and a double and a char and a boolean. Likewise, to set up the input stream, you specify the file source, you connect the in-file stream, right? The file input stream to their file. You connect the data input stream to the file stream, and then file input stream, and then you read it in sequence to those correct variables. So again, we read where here we sent out an int and a long and a float and so on. Here we read in an int and a long and a float and so on. And that's it. It's not too bad. Again, it is very important that the data gets read in the same order that it got written in. Otherwise, things will go off the rails. You will not get the right stuff because the byte array doesn't have any inherent formatting to it. It's just a raw sequence of numbers. You can read that in whatever way you want. Okay. Questions on any of this stuff? Does this all make sense? I hope it makes lots and lots of sense, and no people will have any trouble replicating it on their own. How's everybody doing? All right. Well, I'm going to stop the recording.